My name is Geoff. I work out of Melbourne, Australia. I run the website landsleep.info, and today we're going to run through my theory on how the outer planets control the solar modulation and solar grand minimum. We're going to begin by looking at how the Sun orbits the centre of the solar system. The Sun is basically manipulated by the four outer planets. Jupiter and Saturn do most of the work, but Uranus and Neptune also come together and force their hand as well. So what I'm going to show you to begin with is how the Sun goes around the centre of the solar system, where this red cross is. We call that the Solar System Barycenter, or SSB for short. So this is now a typical inner loop, then moves out to an outer loop, and returns again to an inner loop. That's a little bit of a distorted one. Then it moves again once out to an outer loop again, back into an inner loop, and this is the repeating pattern we get every 10 years. There it's coming into the current situation we're in with a disordered orbit, and once again extending out to the outer loop. Now, if we have a look in detail, if we slow that down a little bit and we look at the current situation, I've done that in green. The normal blue lines here is the standard orbits, if you like, and the green one is a disordered orbit. Now, Dr. Sharatova, some 20 years ago, recognised that when there was a disordered orbit, the Sun slowed down, but didn't really take it any further. Now, today we recognise how and how often and how to distinguish between disordered orbits to see how much the Sun's actually going to slow down, or what type of grand minimum we're going to have, like we're having now. Now, if we look at this green orbit that we're in now, you can see it's quite different from the standard inner loop orbit, and that's caused by Neptune and Uranus being in a particular position. I'll just highlight that position. I'll bring that into frame. Now you can see when Neptune and Uranus are together, or close together, they don't have to be right together, with Jupiter in between them and Saturn on the other side, that's when we get our disruption. That's when the disordered orbit happens, and only then. Now, the position of Saturn is crucial to what type of disorder we're going to have. The shape of this disordered orbit can vary. If it's around about 30 degrees away from the perpendicular, that would be the strongest position, and that's the greatest perturbation. And if we move around to the other side, we've got what we call a type B, which is much weaker. And if it's in the middle of the two, like we saw in 1970, that's also a very weak disruption to the Sun. So this position over here is by far the strongest. And if we go back over the Holocene, every time the planets are in that position, we always experience, or nearly always experience, a large grand minima type event. Now, if we have a look at the actual shape of the orbit here, we can see that the Sun is basically in its orbit path around the centre. Its angular momentum is changing. Now, we can actually look at or graph this angular momentum, and Carl Smith, back in 2007, he plotted this angular momentum. He used the JPL data and some software that he created himself, and he plotted the angular momentum of the Sun as it orbits around the centre of the solar system. Now, this data is, like I said, it's from JPL. It's been backed up by many. It's been cross-correlated. It's checked. It's 100%. So it's solid data. And basically, you can see it's a sine wave that's based mainly the influence of Jupiter and Saturn, but Uranus and Neptune also have an effect. And when they're together, like here they're not together, when they're together around here, we get higher peaks and deeper troughs of angular momentum. And we also get, when we have this type of configuration over here, we get a perturbation. And I call this an AMP event, and which stands for angular momentum perturbation. And you can see there's different shapes. There's different amounts of kick out. Now, this also coincides with the disordered orbit. So the larger the disordered orbit, the greater the perturbation. and also the greater the solar downturn or grand minimum event that occurs. So this is part one of many in the series. So we'll wrap it up here and we'll move on to part two.